In section 2, what we're going to be looking at is linear equations in one variable. Linear equation in one variable are going to be things such as straight lines. That's why you see things like the word linear, because linear, you can see, has the word line in it. So we're going to be looking at straight lines such as like y equals mx plus b, those type of problems. So you can see on the right, I have some red steps for us to look at this. And the first part we're going to be looking at is solving a linear equation. So say you're given the problem 3x minus 6 equals 0. Your whole goal is you want to be able to get this little bitty x by itself. So you're going to take the original equation. This is my equal sign. I'm going to get that x by itself. So I like to move the negative 6 first. So what's the opposite of a negative 6? It's a positive 6. So as long as you do it to both sides, you're mathematically correct. So I'm going to add 6 to both sides. That gives me 3x equal to 6. Again, we're trying to get this x by itself, so the next thing we're going to do is get rid of that 3. Whenever you have a 3 by an x, that's like 3 times x. So the opposite of multiplication is division. So you can see step 3, I'm going to divide each side by 3. So this gives me x equal to 6 divided by 3, which is 2. Once you finally get x by itself, go ahead and put a block around it. You're good to go. Alright, so let's look at this next one, and we're just going to kind of step it up. Math is definitely a stair step, so if you get lost anywhere along the way, make sure you're asking questions because, if you miss a step, I don't want you to not be able to do something further on. And as always with these videos, you can always pause them and go back and replay them if you need to. So with the next one, what I want to do is I want to take the original equation, 5x plus 4 equal to 3x minus 8. And again, I do want to solve for x, but you'll notice that this time, this time I have an x here and here. So the first step that I have to do is I have to get all of my x's together. Now here's my equal sign again. If it helps you out, definitely draw that line down. In order to get the x by itself, I've got to get all the x's into one place. And so you'll see over here, I'm going to subtract 3x from each side. Now maybe you want to move the 5x over. That is still correct. Make sure you show your work. And as long as you're mathematically correct, you'll be okay. With most exams, if you have to take them in a testing center, then I will be looking at your scratch work. And it's okay if your steps look a little bit different as long, again, as you're mathematically correct. And so I like to move the smaller one over, and so I'm going to do the opposite of a positive 3, which is a negative 3, and I'm going to say minus 3x on both sides. I cancel that out, and I'm left with 2x plus 4 equal to, that canceled, negative 8. Now we're just like the example in part A, so I'm going to subtract the 4 over. You'll see that here I subtracted 4 over, and I have 2x equal to, let's see, negative 8 minus 4, that's a negative 12. And then divide both sides by 2. So that gives me x equal to negative 6. And so the first thing that I did was I had to get all my x's to the left or to the right. It does not matter. Again, I like to move the smaller one, but it doesn't matter. We're all going to end up with the same answer in the end. After you move your x's over to the side, then you're looking at example like in part A. You had to move the 4 over and then divide. Now in this next one, I have a lot of it typed up, but I'm going to write and show you what I did along the way. When you're faced with a problem like this one at the top, most people, it's these 3 and 4 that totally freak you out. You know, if I drop the F word like fraction, people in math totally freak out with what they're doing. So with this thing, what we're going to do is we're going to do a little magic, little hand slide of the hand here to get rid of these fractions. And so here's what you do to figure out, how do I get rid of these fractions so I can solve it like part A and B? Ms. Object, you totally had me in A and B, but now you lost me. Well, what you're going to do is you're going to look at the whole problem. You're going to think, what number does 3 and 4 have in common? So a lot of times we call that the least common multiple. And so I'm going to say, what is the least common multiple between 3 and 4? And that would be a 12. So I'm going to take this entire problem and I'm going to multiply it by a big old 12. And in doing that, it is going to amp up the 2, but hopefully it'll get rid of the 3 and 4 on bottom. And you can see in the next step that I've written 12 in front of each term, because as long as I do it to everything, I'm still mathematically correct. I'm just kind of amping up the equation. And you can see that this has an LCD. They talk about LCD because also if you were looking for common denominators, that's the lowest common denominator, or we can talk about it as being LCM, the least common multiple between those two numbers. When you distribute the 12 to the x, this is like 12 over 1, so you do 12 times x, That gives you 12x over 3, which reduces to 4x. 12 over 1, you multiply it by 3x over 4. 12 times 3 is 36x. Divide by 4, that's how I got the 9x. And then 12 times 2 to give me 24. So you multiply each term by this nice number, and you'll notice that in this problem right here, I no longer have any fractions. So then all I have to do is combine like terms. So I put the 4x and the 9x together to give me 13x, and then divide both sides by 13 in order to give me 24. So even with your faced with a problem that has fractions in it, don't fret. Look, don't fret over fractions. Just multiply by something that's going to get rid of those for you. So you can see I got 24 over 13, and so the solution would be 24 over 13. Okay? I don't mean to move it around on you there. So the next thing we're going to look at is finding intercepts algebraically. So there's three. There's like two main things in doing this. Solving for x, we threw in the fractional stuff, and finding intercepts algebraically. You cannot use a graphing calculator in this course. Welcome to college algebra, where we're going to do algebra, not graphing calculator does all my work for me. And so we're going to look at intercepts. And so I have all of these words. Let me read them and talk about them as we go. It says finding intercepts algebraically. Because all the points on the x-axis have a y-coordinate equal to 0, and all the points on the y-axis will have an x-coordinate equal to 0, you can use an algebraic approach to find x and y intercepts as follows. And I'm going to move it up here so you can see it. So I'm going to say finding intercepts algebraically. Here's what we're going to do. We are going to find x-intercepts. You set y equal to 0 and solve the equation for x. To find the y-intercepts, you set x equal to 0 and solve the equation for y. So this is going to be how I find my intercepts. So here's an example. Y equals 4x plus 1. That's my equation. Whoop, keeps moving around on me. Y equals 4x plus 1. I want to find my x-intercept, and I want to find my y-intercept. Now, if you write this as an ordered pair, when you're looking for an x, you're going to zero out your y, and when you're looking for your y, you're going to zero out your x. So look, I have half of my ordered pairs already filled in. So in the first one, I'm going to look for my x-intercept. So this is my x-intercept workout here. I took my original equation, I plugged in 0 for y, and then I'm going to solve for this x. So this is like that example A that we did in the very beginning. So this gives me -1 equal to 4x. Divide both sides by 4. So it gives me x equal to -1/4. So that's going to be my x coordinate for my x-intercept. And the next one, again, I'm going to take my original, and this time I'm looking for my y-intercept. And I'm going to set x equal to 0. Now, good things happen with this one, because what's 4 times 0? Well, that's a big 0. So I just get y equal to 1. So if I'm looking at my y-intercept, I can plug in a 1 for that y value. So the x-intercept of y equals 4x plus 1 is -1/4, comma 0. And the y-intercept is 0, comma 1. And so just be careful when you're working through this. Whenever you find your intercepts, go slow. Make sure you're plugging in for the opposite letter with a 0 and solve algebraically like you did in the very beginning of this lecture. If you have any questions, feel free to ask. Don't just sit around and not understand. I do want you to be successful with this section and with this course.